So Elif else. So you guys have all this, right? In your notes?
Yeah.
We've talked about all this. I think we did a lot, right? Is that not right? We just did a lot.
Yes, sir.
Okay, we can just end the class here now. Should we end now?
Sure.
Okay, so, and that will be
We should do a Q&A before ending.
quality assurance
Questions and answers.
now.
Yeah.
Oh no,
Maybe
no,
today.
maybe on Wednesday.
Okay.
On Wednesday.
We have got 112 assignment submissions.
112?
Yeah.
Yeah, all the weekly, everything. It's going to take me a while for the grading.
You've got a lot of
Professor, are we sharing the link or?
Yeah, I'm gonna give you.
Just like that, but you have to give the assist to the professor.
Oh,
Me.
where? Here?
So you have to write
Send
comment,
me
you
the
will
link.
see an icon.
Just you have to use link this link.
You want to open this link viewer.
Comment user? Role viewer or comment?
We can do like
Or
comment.
any other.
Yeah, you can put your link.
I'm a sword.
Put the link in the week 16 participation.
Like
Big
a
16
message or like a
Just-
integrated document file.
You can do notepad or copy the link. You can copy the link and paste it or
On the message.
on
Yeah, there is
Brochure.
in the comment section. We can do it in
Or on the
comment
comments.
section.
Yeah.
No, we have here a file for that. We can't do the comment section.
I don't understand that. Let me see how it shows in your on your laptop.
We have to do in MS Word. I think that.
Let me see how it shows.
No,
You don't know how to use this one.
Let me see how it shows.
And you can go submit that.
Yeah.
Oh.
It's so smart.
Assignment and where?
Hmm?
To submit to where?
Week 16.
I'll just record a video.
No, don't record.
Of participation.
Use notepad. I'm expecting a person.
Oh yeah. Notepad is good.
So can I use the MS Word?
Use notepad. It's very quick to open it.
Okay.
So,
Professor, the website say I need to add file.
yeah. So
TXT.
copy the link and paste it to the notepad. You know notepad?
Oh, okay, I got it.
Notepad is very light, so I don't want Word takes a while to open.
Professor,
Yeah.
I have pasted the link in comment and
Yeah, we will do this. Yeah.
Notepad file.
It will be easy for you.
Let me see. I've got to Pascal in.
Yeah, no, I just submitted it.
Yeah, so I'll just So do both comment and notepad.
Yeah, that's mine.
Okay, cool. So don't forget what I told you. All the code we've done from week 1 to week 16 minus this one. Try to put all of them in a single notebook. Run it, and send the link to me. That will give you 5 points extra. You got it? Like all the week 1, week 2, week 3, everything we've done, you have it. Try to run them in one single Google notebook.
But that will very, Professor, that will very long, the code. If we put everything together.
No, you just put the week 1 in the comment. Yeah, it will be very long, but
Like week 1 to week 6.
it's like you are reading for the exam. I just want you to read everything for the exam.
Oh.
So when you do that, you're already studying for the exam.
Okay, got it.
So you don't have to go to the PowerPoint or read anything stress yourself. When you read all the codes and run it, right?
Yeah.
You're ready for the exam. I'm telling you.
Professor, can I please check my
Yeah. Let me check. I think we can go now. Oh, be back.
And then Professor, can you check mine?
The one I told you about?
Yeah.
I'll just ignore it.
We can please check mine.
Okay, cool. It's working.
Okay.
Yeah. That's yours. This is yours.
What?
Professor, mine?
Let me check. Ashish up.
Ashish, yep.
Yeah. Cool. Working.
Thank you.
Yeah. Any other question before we go? Wow, it has been wonderful time. 16 weeks.
Go like this.
We meet 4 times a week. 4 times, right?
Yeah.
Monday, Wednesday, Friday, and lab. That's a lot. If I don't see you another 10 years, I will still remember you in my head. The image, the memory.
I will miss you, Professor.
We will miss you so much. I know you are already living on.
Yeah.
That's so bad. I don't like it. You have betrayed SMSU.
Wow.
California is fun.
Okay, see you.
All right. Be blessed. Can I go?
Yeah, sure. So
I'm super, super hungry. Okay. Yeah, it's wonderful to have you guys. Our students. Okay. Yeah. Python is leading everything now. You know what? I've told you 5 languages 5 software techniques you must know. 6. Number 1, listen. Python, JavaScript, Java,
and C++.
SQL,
Oh, okay.
C++.
Nice.
But if you want to add more for web, HTML and CSS, cascading style sheet. See ya? Remaining. Yeah. O ṣé o. Èmi ò yìn Olúwa ọba tí mo mọ̀. Ọba tí agbára rẹ̀ kò lákàwé. Ọba tó jókòó lórí òkè mímọ́ rẹ̀. Orúkọ rẹ̀. To 3. Kókó àwọn tó máa present. Billy. Èpè. Èmi ò yìn Olúwa ọba tí mo mọ̀, ọba tí agbára rẹ̀ kò lákàwé. Orúkọ rẹ̀. Sean, how are you? Starting 3 o'clock?
Yeah, kind of.
I'm too tired.
Wait.
You what? Yeah. Oh, equal. Oh. Ìlú tó ohun ìgbàgbé Jerusalem, ìlú Ọlọ́run. Ìgbà wo la wá rojú? Oh, okay, I'm a student. Láwa rojú. Ìlú nínú ìlú àìjà Ọlọ́run. Ìlú. Ìjà nínú ìlúdé Jerusalem dára ọkàn mi ṣàfẹ́rí rẹ̀. Oh. Delete Sarah. I'm not going to change this. All around. Níbi táwọn dáadé ẹ̀mọ́ lẹ́nu rojú onímọ̀nà oníṣòwò ọ̀fẹ́rẹ́ yẹ ọ̀fọ̀. Jerusalem, Jerusalem, ìgbà wo lóbi. Ọba alágbára. Ìgbà wo ìrìnàjò ìlú nínú ìlú àyàjọba Ọlọ́run. Ìgbà wo ìrìnàjò. Ojúmọ́ ìjẹ̀mú. Jerusalem dáhùn ọkàn ṣáfẹ́. Jerusalem. Jerusalem. Ìgbàwó láwọ́rọ́ jù. Ìlú mímọ́ ìlú ayọ̀ ìjọba Ọlọ́run. Ìgbàwó ìlú mímọ́ àwọn ojoojúmọ́ ìjì nínú ìjì lóde. Jerusalem. Ìlú Ọlọ́run. Ìgbàwó ìrìnàjò. Jerusalem ìgbàwó. Ìlú mímọ́ ìlú ayọ̀ ìjọba Ọlọ́run. Ìgbàwó àwọn ọkùnrin ṣáfẹ́rẹ́. Aṣẹ́gun ìgbàwó ìrìnàjò. Ìlú Ọlọ́run. Ìgbàwó ìrìnàjò rẹ̀. ìjọba ọlọ́run ìgbàwó. Gigi lode. Nigeria, ẹkú ọjọ́ mẹ́ta. Ẹkú ọjọ́ mẹ́ta.
Látọdún mẹ́rin sẹ́yìn mo ti dákẹ́ jẹ́. Mo sì sọ̀rọ̀ láti bàtà rẹ̀ lọ́kùn wá ló ti lọ. Kì í ṣe tilẹ̀ bẹ́ẹ̀ ni kì í ṣe tójú. Tolúwa kò bá darí mi láti sọ̀rọ̀ kan. Mo kò lè ṣàdédé fọ̀rọ̀ jáde. Ṣùgbọ́n Tolúwa bá darí mi láti sọ̀rọ̀. Kò sẹ́nikẹ́ni tó lè dá mi sọ̀rọ̀. Ó sì ti
And it was almost like I told my wife, give me the boy. She said, I said, give me the boy. One day the devil came for my son. And I heard my wife shouting, Jesus, Jesus, Ebenezer, Ebenezer, Jesus. And I went to her, I said, what is the matter? I saw my son. I could only see him foaming from his mouth. And it was almost like I told my wife, give me the boy. She said, I said, give me the boy. And I took the boy, went into my room. She was coming, I said, stay back. And I dropped him on the floor. And I said, Satan, the error is that I'm at home today. You made a mistake for this. And I spoke words. Am I speaking here? Words into his life. I know a woman in my church. She's in the women department. Her daughter died on a Thursday. And the woman took the daughter from the hospital and took the daughter to her room. She prayed the whole of Thursday. The girl never opened her eyes. They prayed the whole of Friday. She didn't come out. The whole of Friday, the daughter was still there. People wanted to break the door open. She said, leave me on my door. She prayed on Saturday. At noon, the daughter came back to life. Am I talking to somebody here? That's a woman who was saying, I'm not taking no for an answer. This is my child. The word of God has said to me. The word of God has said to me, I shall not bring forth for trouble. The word of God has said to me, you sons of Jacob shall not seek me in vain. The word of God has said to me, gather yourself together. You shall be broken to pieces. Associate yourself. You shall not stand. For Elohim is with us. Who is he that says a thing and it cometh to pass when the Lord commanded it not? Have you not heard? Have you not known that the everlasting God, the creator of the ends of the earth, neither offended nor is he weary? For there's no searching to his understanding.
Yes.
They give it
Out to the weak.
to the faint. The young man may fall and the youth may utterly fail. But they that wait upon the Lord shall renew their strength. They shall mount up with wings as eagles. They shall run and not go weary. They shall walk and not faint. You don't serve a dead God. You serve a mighty God. He's the same yesterday. He's the same today. He's the same forever. When God says yes, no man can say no. When God lifts you up, no man can bring you down. God is on your side. Power is on your side. Glory is on your side. Somebody shout yes. One day the devil came for my son.
Àwọn kàtí ọlọ́pàá eléyìí ò dáa tó o ẹ̀yin ò láàárọ̀ ọlọ́pàá bẹ́ẹ̀ bá ti dá wọn dúró tán máa ti dúró ẹ jẹ́ kí wọ́n lè kàn máa lọ iṣẹ́ yìí gbàgbọ́n o.
Send lots of emails to lots of people.
Baba is Ayo Babalola. Even when he writes his name in his Bible, he writes Joseph Ayo Babalola, not Ayodele, and I've tried to correct people wherever I can that there is no Dele added to his name. Baba is Ayo Babalola. Even when he writes his name in his Bible, he writes Joseph Ayo Babalola, not Ayodele, and
Oh, fine. Oh no, no, probably going to change that. No. Ah. All I want to be more to be more in my own, in my own, to be my own.
Yes.
Okay. So the project that I worked on this semester is sports performance tracking. So just want to overview on what the project is. The main concept was to first figure out if there is a way to generalize movements within sport. So for example, in football, can we generalize how to throw a football? Can we generalize how to shoot a basketball? Swing a baseball bat? Can we generalize those movements? And then second part of that whole experiment was to see if we can then use that generalized data. Can we learn from that? And then can we see what is the right way to do it? And then can we tell the user how they would change their movement to be the right way to do it? So the journey started in January when I started doing research regarding this, and for research, the first thing that I wanted to look at.
Recording stopped. No. Recording in progress.
The research that I was looking at was what libraries would work for this, because the main concept that kind of everything revolved around was tracking, pose estimation, how to estimate the movement of someone. So I looked at more than 5, but these 5 were the ones that stood out to me. OpenPose is one. MediaPipe is developed by Google. It also does a lot of 2D tracking, but benefit of MediaPipe, it is lightweight, so it can be run on relatively small devices, small regarding CPU size and GPU size. It doesn't need much, and it doesn't need much memory either. MoveNet is a more heavier version of that, developed by Google, and OpenMMPose is an open source library developed by some students. So out of this, MediaPipe, the third one, was the one that kind of stood out to me because it was lightweight, that can be implemented in a lot of different places, and it was versatile because it just needed Python. You didn't need much else. And there were two papers that I kind of looked at for this. There was the Human Pose as compositional tokens. They talk a lot about how the tracking is happening and how it is tokenizing the joints and the angles and all that stuff. And then the other one, the real-time multipurpose 2D and 3D whole-body pose estimation paper. This was the one I talked about, OpenMMPose. This was their model, and they wrote a paper on comparing it to other models that helped me kind of figure out what their metrics were on figuring out what the right model was. So once I did some of my research, the next step was to figure out what the workflow would be, how I would go about getting this. So this was the final we landed on, but in the beginning, the first thing I kind of just started with was doing pose estimation and data recording. And I didn't understand, what I needed to do before that, so I just started with that because that was the most obvious thing. But once I did that, I realized there were a lot of variations in data. So for that, I had to kind of normalize the data. So I then had to set the scale and the skew of the video to make sure all is clean. And then also there were a lot of hiccups with the estimation. So for that, I had to do data cleanup. And then once I had all the data, I would merge the data into a single throw. That would be the mean throw. That would be the average throw of that user. So for 50 throws per frame, it would be averaged out. So for the first frame, if the hand is here, then that would be the throw.
Volume, you can increase now.
So
Increase volume.
And then, so that's kind of where I got to for this semester. This is a 2-semester project. So the second part is for the next semester, which is then we would use it to use the throw that we did for the 50 throws for one user and compare it to the new user. So the first user where we did the 50 throws would be like a trainer who we're learning from, and then the new user would be a learner who would want to learn from the trainer. So then when we do this same thing, we scale and skew the user's video, we do pose estimation for the user, we do data cleanup, and then we overlay the throw to show where they are off and where they deviate from. And then visualize that, show them how they're off. So it was not in the beginning. I ended up with this very far down the road. So the first thing that I needed to do was to standardize the videos. So for that, the one main thing was to make sure all the videos started at one point. So over here, they're all starting where the hand is, the ball is where the shoulder is. Within some variations, but around that point. So they all start within that period. The second thing that I needed to figure out was, as I said, different camera angles, different distances for cameras affect the data collection very much. So for that, I did some research and figured out that Aruco is an open source. It's also an OpenCV. It's open source, and it's a QR code.
No, I'm
right here.
still in.
By Aruco.
Our students are presenting their capstone.
Tell us where so this is generalized. So you can set up how big this is and what it looks like. So this is an ID0 QR code with a 50mm size. So when I print this, the OpenCV library knows that this is going to be 50mm printed on paper. So when I look at it in the video, this knows that QR code is 50mm big, and that person is then, you can scale that person to that size as well. So you know the scale of that person because it's standing right there. So I scale all the videos to be the same size based on the QR code because the person is standing right next to it. So that generalizes that scale and the skew of it, because you can also skew it. You can also change the skew of it because a square, all the corners would be, all the distances from the corners would be the same. So if you change that, you can skew the video as well. The next thing we kind of worked on was, I don't know if you were able to see it, but the pose estimation had a lot of errors in them. If you look at the hand here, you see it slips. When in fast movements, it slips. In the original, I showed this to Dr. Kaiser before, but in the original one, it slipped much more. This is, and we re-recorded the data, which helped with the slippage much less, because now this data would like fly all the way over here. Now it was very much attached to the hand. So that helped a lot with getting lighting and getting a dark background behind it, helped with contrast, and figuring out how to shoot actually helped as well. So another thing I used to mitigate that problem was to do some data analysis and to see how we could fix it. So one way I kind of figured out was to, over 10 frames, you can average, you can see if the center, so if there's 10 frames and the N over 2, the middle frame, is outside of that range of those 10 frames, then the data is too far and it's probably slipping. And if it's, and we want to bring it back, so then I take the average of those 10 frames and then we just replace that value. So we know that data is not too far. So that kind of smoothed the movement out a bit. But also helped us leave a little bit more generalized data. The next thing I did was, so if you look at, because the videos are all different angles and different sizes, we don't know how, like, what the size of everything is. We don't know what the distance of this is, what that is, like, we don't know that. So, did some, so we kind of plotted all of it and to see, sorry, this was actually for, as I was talking about before, was for the slipping. If the data went too far from the mean, then you know that it's out of the data, it's out of where it should be. So this is for the first frame, I have 50 throws, and if the data is too far out of those 50 throws, then it is slipping. So for example, if you look here, the data is too far out, it's not within where the mean should be. So to mitigate that, we are using, as I said, we use the mean to kind of keep it all together. And then another thing was, as I said, the distance between all the different points, we didn't know that because they're all pixels, and pixels don't have distances. Their distances just, we don't know the scale of that exactly. So to generalize all the data, I had a point called the relative point. So every video has a relative point, which is the average of these 4 points, and that lands around here. This is a drawing that I did, and the average is different for all the videos. So if you see the original values for the first frame landed, they're pretty spread out. They're all over the place. The X values are for the elbow. There's a lot where they should be, but there's a lot where they shouldn't be. But then when you took the relative of it, you see that all the values are very compressed and within one range, and they're in a standard distribution in a way. And you have some errors, but we can get rid of that, as I said, with taking the mean. Same with the wrist, as you can see, they're very spread out. The highest values we have is 5 in one place, but then when we take the relative of that, they're all in one place. Same with the ankle, as you can see. So then I took the mean of all the 50 throws. We have 50 throws. I calculated all the pose estimation for it, and then took the mean of all the 50 throws. So this is all the 50 throws combined into one throw, and this is how it throws. And that's the estimation of what that person's throw is, basically. So it's an average of how that person throws. And if it was a trainer and that was the perfect throw, this would be the perfect throw. A version of it, because there are different throws. So then then I tried to overlay this. I was having a little bit of trouble lining everything up properly because the scale of everything, as I said, is very different. So I still have to work on that a little bit to line all the points up and scale them up to be the size of the user or the video. So on the right is the original. As I said, there's a little bit of line of error, but the throws are pretty similar because this person knows how to throw a football and it's very consistent on how he throws. So the throws are pretty similar on how they go about. And so that's where I kind of landed with the project in this semester. And So for the next semester, moving forward, I would the first thing that we would do is figure out a way to overlay the throat on top of the person and find a way to make it visually appealing and figure out a way to show how it looks nice. The second thing would be to find ways to visualize it, as I said, and to ways to compare it. Show what the best comparison metric is. For what I thought was the best, and I haven't had yet to implement it, would be the standard deviation. If it falls outside of 3 standard deviations, then it would be not a good throw, is what I thought would be a good way to measure it. But again, I have not tested it, so I cannot conclusively say that's the right analysis. And then we could, the second big part of this for next semester would be to create an appealing UI to make it look nice, so someone can actually use it and someone can do something with it. This is just right now code that has no meaning to most people. And then the fifth bigger step is when I was talking to exercise science professors and a lot of people that know how sports work, one conclusion that I came to is there are different bodies and every body has a different mechanic. So the best way to move forward with this would be to generalize people, not to generalize people within one group. We would have to go about and categorize or classify people within different heights, different body weights, different biomechanics, so how long their arms are, how long their legs are. So the larger the classification, or the larger the groups are, the larger the amount of groups are would be the better, but that is not realistic, so we would have to find a happy medium where we can categorize people within like 10 groups and then find a way to do it, male and female and all that stuff. So that would be another whole different aspect of it that we would have to look into. And that is all that I have, and then I can show some of what I have a lot of it on the video as well, on the slides as well, but basically the 5 steps it's kind of taking right now is, the first step is to do the scale. So it's taking the marker and it's scaling it to, I have it scaling to, so as you can see, it has the marker ID and 50 millimeter is the printed size of the marker. So then in the main, so in the main, I then tell it what size that I want the marker to be. So then I tell it if it needs to be 70 pixels big or 100 pixels big, then it will scale the video. So all the markers of those 50 videos are 100 pixels big. And then they're all scaled to the right size. So that is the first step. And then the second step, it will take all that, take all the videos from the data set that we have. So my data set is over here. So I have about 49 different videos. So it will take all these videos and it will then do pose estimation on it, and it will spit out CSVs. So the CSV just is basically X and Y values of each thing. So shoulder, the elbow, and wrist, and basically every point there is, it just spits an X and Y value for that. And then it also calculates the relative X and Y, which I said was the center value, the distance from the center value. So that actually helps as well keep the data generalized. And then the third step is to do data cleanup, which I said was we needed to do some estimation of mean, or to clean it up so it doesn't fall outside of that 3 standard deviations. So it's not like just throwing itself all over the place. And then the fourth step is to take all the 50 throws. So we take all of these CSVs and process them and take the average of all 50 of them and then combine them into one CSV. So then we get this CSV that basically has all 50 throws averaged out, and it just has all the values from those 50 throws. And once we're done with that, then we overlay that on top of the video. So this is then the last overlay. But yeah, that's the last overlay. That was the video we saw at the end of right here. So this is the last overlay that it shows us. And also this one, it also splits up this overlay. This is the printed CSV overlay. So that's what it's kind of doing right now. And in the future, we'll add more functionality for the second semester.
So when you make your first million make sure you do a nice donation to the SMSU Computer Science Department.
I have a question. That was a good work. In the library, the first 4 lines of your code, I saw a library that you imported. Was it import globe? So I understand the CV library, but that globe, what does it do? That library, what does it do? Import globe, yeah. In your source code, the first 4 lines, the globe library, what does it do?
So that's getting the global path of so it's taking the path of the. So I'm using a lot of different folders, so that's a way to get the path and then join different paths on top of that.
Okay.
Yeah, and so I'm taking the base path of the folder that has the videos on it, and then I'm making new folders for every time I want to do the analysis. I'm creating a new folder for the CSV output, for the video output, for the trimmed CSVs, and there's like 5 different folders that I need to create. So the global library that does a lot of the joining and parsing of that.
Okay, cool. Thank you.
And I think that's all I have.
I like your work. It's a good job.
Yeah, sorry. Yeah, I didn't notice that my microphone was disabled. Yeah, good job, Moise. And number 2, I believe, is Abiya's. Yeah. Abiya, your key.
Yeah, we're gonna share our screen soon.
Yes.
Okay. This is our website here. It's a presentation. Sorry. There we go. Okay. So we continued our project from last semester for the Marshall Bus Scheduler for this website.
If you could go to the and for the project description, I'm sure you guys are familiar with it, but just to go over it, the Marshall Bus Scheduler has been updated to add key features that it didn't have last semester. So if you guys remember, this is a 2-project semester. This is a 2-semester project, my bad. We have key features such as usual login and usual logout. Forgotten passwords can be reset through an email. Usual login allows users to database.
Ṣòwò ẹni pé àjísọmọ olùbí òkú ṣòwò lágbára ṣá. Ayọ̀ yóò jẹ́ tiwa ní Jerusalem. Ayọ̀ yóò jẹ́ tiwa ní Jerusalem. Ayọ̀ yóò jẹ́ tiwa níbẹ̀ òun. Ayọ̀ ènìyàn.
Making sure that the code is well documented for editing as the project grows, because one thing we realized that it's very easy to forget what progress is made, especially if you're working on like 2 different platforms. Because we would write the code on VS Code, and then when we realized that like the live show was terrible there, we moved everything and pushed it all to GitHub. And then in the process, information got lost, and then we had to restart at different times with different portions of the code. And so having like a place for where all the code is properly documented and up to date, where everything can be accessed, is super important.
And with that, oh sorry, go ahead.
Go ahead.
No, with that we changed all of our database our booking and payment page. We used everything from the database instead of from the HTML pages. So when we were updating that and switching that, the documentation was pretty important to make sure that you could see what you were doing correctly.
Yep. And then also include specific error handling and log them in the console to specifically track what is causing errors. And then deploying the website, like I said before, deploying the website on a public server would allow broader access to the website in real-world testing.
And then this was our time log, and these are our sources. So then, this is our website.
Yep. Starting off with the homepage, we just decided to make it a little bit closer to home with Marshall. So we've got a welcome to Marshall, Minnesota image there. And then just like right below, there's the description of the routes that are already available.
And then we edited this top bar here. So we added the running page. And then we used to have a bookings tab right here that you would click on, and then it would take you to the payments, but now you get to that through logging in. So we removed that. So this is our schedule for Dial a Ride, and it once again lists the prices that are for each ride and the time and age of the person, and then this is an image of the bus that people use for Dial a Ride.
Just so we put that there for new users who might not be familiar with the Marshall area, just so they can know like what's going on and like what the bus looks like, and they know what to look out for. And then we have the bus routes, like I said, mentioned before in the homepage, but we just put this here specifically so that like people can see what times they're able to actually like get the bus, because a lot of people aren't aware that the bus doesn't always run. And then for the Dial a Ride, we also have like the specific timing, and we have our Google map right there, just so that whoever is looking for their stop or whoever wants to like figure out where they're supposed to go, they can access the map and figure out where to either wait or where they need to be. One thing that we would have liked to do is probably have like a live tracker on each bus, but that's something that we're going to need the permission of the Marshall community to do. We can't just randomly like plug a tracker into each bus and then hope that no one's going to be, suspicious of that. So that's a limitation that we have with this project.
So then this is our newest addition. So we created a login page which uses an email and a password, and then this is the create an account page. So each of us have already created an account. So if we were to try and create the new account, it would cause a server error. So it's kind of hard to demonstrate right now.
I mean, would anyone be willing to give us their email? Professor Mann, would you like to give us your email so we can demonstrate?
Okay, mans@smsu.edu.
Okay, so then if we did a password like 123, if we put in the wrong password 1234, it would cause an error that says passwords do not match. So then you can adjust it and do 123. We also created a terms and privacy page that just is like basic privacy and terms and conditions policies for websites, just saying that we're using your information in our database and that kind of thing.
Yeah.
So then if you did the password and you click create account, it would say accounts created successfully and you would be able to log in. So then if you log in, I don't remember what my password is.
I think it's 1234.
1, 2, 3, 4, 5. Okay. So then we log in, it says login successful, and it takes you to the bus booking page. So here we can create a booking. If we did it right now at 3:30 p.m. and we did one adult and one child, the adult would be $2 and the child would be $1. And with Pay Now, it updates the amount here to $3. And then we can
And for now, we're just gonna add random numbers because we really don't want to expose anyone's card information, especially on this demonstration. And another thing that we kind of ran into is we realized that we wouldn't be able to actually collect people's money and payments without this is something that we need collaboration with the Marshall community to be able to take this a step further. So we can't just collect people's money on the internet. That's would be considered fraud in some cases, especially if the money doesn't end up going to the Marshall community. So that is a little restraint, that's a little setback that we have, but it all depends on whether we're able to push this to the Marshall community later on. And then you can go ahead with the expiration date, like an older one.
So I'm going to put in an expire in the card, and then if I press submit, it just tells you that this card is expired. And then if I were to do a correct expiration date, it says that the payment is successful, and then it takes you back to the booking page. Here you can log out. It says you've been logged out, and then it takes you back to the home page. In the home page, if we were to go back to login, we can reset a password. So I'm going to send a reset link to my email. And then it says that if it exists, it's sent. So then I should get one. Yeah, here we go. There it is. And I can enter a new password. Let's reset. And it takes me back to the page. And then if I were to try and enter my old password, it would say no. But enter my new one. It's back. I think that's
Yep. And we're able to do this with, using the back-end integration. That was super important, and that was a key factor that was missing last semester with this project. We didn't really have a well-put-together database, especially a database that included like users and login and all those other types of tables. And then, like Sari said, using Express to put this back-end together using Node.js was one of the biggest learning moments for us on this website. We know that there's more that we could do, but like we said, there's a couple of limitations, especially since we can't really collect people's personal information without the permission or without the authorization from an actual legit organization. But for now, this is what we've got going on. And the live clock is something that we could improve on, is actually making the live clock send reminder notifications to user emails. But the way it goes now is just, it's there on the website just so that people can have like a mental reminder that, hey, I have a booking for this time. The time is, time is ticking. I need to pay attention. And that's what we've got. Thank you.
Right. So yeah, I think where you first started, you put like the red route, what is the blue route? I think if you could include in a map, like the Marshall map, and then like the red lines where it covers. So I think.
Yeah. Yeah.
That looks nice.
Okay.
Yeah.
And then I don't think we clicked on it, but there is a link to the actual Marshall community website, just in case people want extra information and they're not like.
Right.
Our goal is not to provide all the information that the Marshall community website does. But we want people to be able to access that information, so it's there. And I think that also has a link to the map. So that was one of the reasons why we didn't put it there. But that's a really good suggestion.
Yeah, my point is just like when you design a web application, think about visual effect.
Yeah.
That's why. And when I saw you have a red, red wrap, and I thought, oh, if it's a red font, maybe looks, that's
yeah.
Right. So it's just some idea. Yeah. Okay. The design, the sort of design.
Yeah.
Thank you.
Thank you.
You're welcome.
Can you hear me? Yes. So I'm gonna present about my piano chord recognition with machine learning. So the topics that I'm gonna cover is a brief introduction about the project and the machine learning aspect of the project, how it works without getting too technical, and the front-end implementation. So this is my capstone project, a real-time piano chord detector, which is called Live Chord Identifier. It's a web application that listens to live audio through the microphone and identifies musical chords being played. So the primary goal was to help musicians and learners recognize chords as they actually play it, which really offers an immediate feedback for practice and education. For the machine learning part, I mean, while I didn't train a custom model from scratch, I leveraged a pre-existing algorithmic approach based on music theory. So the app uses signal processing techniques with the Web Audio API and FFT to detect frequencies. Then it maps those to note combinations and fetches the most probable chord from a predefined chord identification system. So essentially, fetching from an API. So in terms of how it works, the process starts by grabbing the live audio input from the user's mic, and the signal is analyzed using the Fourier transform to extract dominant frequencies. And these frequencies are compared against note patterns, and when a match is found, it dynamically renders the corresponding chord with proper musical notation on the screen, that is. So that it updates in real time, offering a smooth transition between chord changes. For the front-end implementation, so I used React and Vite to keep things lightweight and fast. The interface is minimalist with a central focus on clarity. So there's a waveform animation that reacts to volume, the buttons to trigger the microphone, and SVG-based chord rendering that mimics sheet music visuals. And I've also added hover effects, responsive design, and dark mode styling to improve the overall user experience. Now I can go ahead and demonstrate. So, as I talked about before, this is the minimalist design that I have. There is a help and about section here. So this section of the website, it gives the user a quick overview of how to use the app and what's really happening behind the scenes. So under this tab, I actually guide the users to get the best results by minimizing background noise and playing notes clearly. It explains that the project is powered by the Web Audio API and that I use Bayesian filtering to identify chords in real time. And you can also find my GitHub and LinkedIn for anyone interested in learning more about the project and the source code. So this graph right here is a screenshot that I added. It's just a visual representation of the power spectrum generated from the Live Audio API. So each peak represents the intensity of a frequency component, which is detected in the sound. So the red vertical lines indicate the frequencies that have been identified as a musical note, and which are then analyzed together to determine the play chord. So this visual helps explain how the app filters out noise and overtones to isolate the most prominent note in real time. So this is the enable microphone button. If it's your first time using this website, there is a prompt asking you to enable microphone. Since I already did that, I don't think I'm supposed to. So yeah, this is actively listening now. Since I'm speaking, I don't think it's identifying any chords. I'm going to go over my piano and play some chords here. So now I'm going to play C major chord, which is just flat chords, so there won't be any sharp signals. There. Now if I play D sharp major, then the middle one would have a hash key. E major chord, no hash. There's a flat in here. I don't really know if I can't really determine. I mean, I can't really show it to you guys if you can't read notes, you know? How can you guys know if I'm playing the right chord or not? But I'm saying it right.
Some of us can.
But yeah, one of the problems with this is if I actually play a whole piece, then I can't really keep up with my pace. So that's one of the drawbacks that I'm trying. And I can't really keep up here. There's a lag, you see?
Well, we can't hear the notes because Zoom is considering it background noise.
Oh God! But yeah.
You can share, share like video or something.
Okay.
Share options, or should I?
Where do I do that?
I think under share.
Down.
Sharing your screen.
Below.
Go down to share.
The green button down.
Share options. No more options.
Go down to share. Go down to share. Click on the share.
Share is down.
Yeah, there's
The green button
split,
down.
and somewhere at the right or top there's a.
Oh, share sound?
Yeah.
And then share?
Yeah.
My God. Is this my computer password or my? There.
That works.
Try it.
You guys hear it?
No.
Not yet.
Oh well, that's okay. That's okay.
But yeah. So I'm actually playing the piano though. So why isn't that? Oh my God. I think it's because the thing that I did was Zoom took
Right.
Yeah.
Right.
Yeah. But yeah, that's essentially how it works. It is pretty accurate. I don't know how to, prove that to you guys, but yeah.
Oh,
So yeah. That's what I know. Thank you.
Cool.
Good job.
I was gonna go next, but Samson just texted that he needs to go somewhere, so it's okay. He can go and I'll go after him.
Thanks, Ami.
Oh. Sleep and catch up. Sorry. to mute. Yeah.
If you're speaking, we can't hear you.
Not muted.
You guys hear me?
Yeah.
Okay.
Okay, perfect. How about my screen? You guys can see my screen, right?
Yes.
Yeah.
Okay. So, my project is it's basically social media or like it's a directory for developers, and we just create this small community for developers and just showcasing different projects, events, jobs, and things like that, and like doing these discussions, receive feedbacks, and basically creating this small community for developers. I use Django and I'm scrolling for the database. For the front end, I just used HTML and CSS. Mostly I focused on the back end. So just show her, this is the front end. Kind of down to everything here. So right now we can select whatever they want. There is the projects part here. If you go down the hackathons, different events, and different community posters posted by different users. You go up, you can view projects here, or you can just go here and select the projects. I'm still looking. Oops. Just looking some user. They can register for login, but I'm just looking for a showcase it. If you look in here, they can see projects, with projects. Any user can edit, not any user, but like the user that I just put in can edit and delete. Or they can ask for collaboration here. It's same that I would just show to you on the back end. The second thing is that I've been working on is the message part that it took me forever to fix and to work on, but it works now. So a user can start a conversation with a different user. They can select the users here. Let's just select this one, and they can say hey, hello, like just say hey. I'll show you back. This one's over. And that's it. They can just text whatever they want. And the other features is the community part that I've been working on. So anyone can post developers in a country, any groups they want. Over here there is the Python developers only group. So they can join or leave this group. For now I join this group. I can just simply leave the group or join the group. Since I created this group, I can do edits, like to fix some stuff. I will work on some rules here, so that the user can create some kind of rules for its members. And I can also create a new group here. Let's see. Other features like jobs. For the jobs, the admin is the only person that can create the jobs. So here's the first job, the contact info, the discussion, not the discussion, the description. Other feature is the learning resources. People can post any helpful resources for their members or like for people in the community. So this was the that I just put in this morning for the machine learning tutorial. I can edit or debate or share over here. I can search for the resources that I want. I need to add more tabs. Like I said, I've been working on most of the time on the architecture part. So you can easily search
whatever the resources that I want. So these are the features so far on the front end, and I will quickly show the back end here. To start, we have all the users that I showed you earlier that are registered, and they can log in, log out, whatever they want. The community posters that I showed you earlier are over here. The events, the groups that I showed you, the hackathons. Of course, the admin can add any kind of hackathons if they want. The jobs, the learning resources, and the conversations that we did earlier. I said, hey, it's over here. So I think that's all so far. Oh, the collaboration requests that I did earlier is over here. Who requested who. So far, this is the project.
Okay, so Ali next.
Yeah, I can go next. Let me see if we can share. Alright, can you guys see my screen now? Yes.
Yeah.
So I worked on a real-time parking lot analyzer. It's basically a real-time image classification, but with a custom machine learning backend, and the image classification itself was implemented for parking lots specifically. So the way it works is that you basically upload a video and an image, and then on the backend processes itself, I use a pre-existing machine learning model, a .p file that I can talk about later if you guys want. And then it'll classify empty and open and unused parking lots in real time in front of you. The tech stack was pretty simple: OpenCV for transformations, and then Pillow for conversions. Scikit for the machine learning model itself. Overall, I primarily use Python, and for building the front end, it was Streamlit. And then for future, if you want to have a visualization for graphic or plotting, we can use Matplotlib, but for now it was not used. It was more of a future thing. And then for the graphical user interface, it was Streamlit, as I mentioned earlier. Yeah, so the pipeline, the way it works is that it's going to resize all the pixels of the video that you upload. There might be grayscale conversion as well at the back end, but obviously what you see is going to be in color. All this is to make sure that at the back end it's as light as possible, and for future reference, as scalable as possible. Streamlit UI, and then there's a processing layer. There's a model P that I mentioned earlier, and then after that, there's multiple Python modules, for example, utility and more, that kind of brings it all together. And then I can demo it right now for you. Yes. I think I'm wrong keyboard. You guys can still see my screen, right? Yes. Alright, so this is what pops up. We can make it more aesthetically nice, maybe add some more text over here, perhaps add another page, maybe for a future project we can make it more natural. And then first thing you want to do is drop this mask.png. This is basically that grid that'll actually change its color based on whether or not we have a parking spot over there or not. And then the next thing you want to do is upload an MP4 file, for example over here, this one. And then there's two main features for this. There's a live video analysis and a picture-by-picture analysis. We'll do both of them. To start with this, the live video analysis, as you can see over here, there's a lot of actions. Yep, and then you see a total number of available spots. as they get utilized, it's all happening in real time. So yeah, if you see this one converts into red, but then the moment it passes by, it again converts into green. So it's fairly quick. There's not a lot of delay. And then for security reasons or for any practical implementation, if you want a picture-by-picture analysis, you can click on this, and then this entire video is we're going to do each individual frame. So it becomes a fairly large file, a lot of swipe, but for any particular reason, if you want to do this, if you need this feature, it's also available at a click of a button. Now you can just go ahead and end it. Back to the presentation. There were a bunch of technical challenges for this one. The biggest one was the model. First of all, I had to find the model that kind of fits the whole thing. Also, it was easier for me to integrate using Python and no other language because I'm most fluent in Python. So I had to find the pre-existing model then, make sure that my model, the front end, not only worked, but the performance was optimized well enough that practically can be deployed possibly from a capstone too. Talking about the use cases, first of all, we already see that in terms of real-time parking availability for shopping malls, it's already being deployed. Oftentimes when you drive in a parking space for a bank, for the Mall of America or perhaps any other mall, this is basically a more complicated version of this is what they're using. What people don't realize is that this can also be used for possibly smart city infrastructures for future cases. Obviously, we're going to have a lot more smart cities, more technology, so this can help with that as well, especially when it comes to data-driven planning. If you have this data available in your computers, perhaps when you're designing a city, when you're designing more infrastructures, you can take this into consideration. And lastly, surveillance and security. That's why I added the frame-by-frame analysis. If there's any sort of dispute amongst two drivers, maybe there's court needs these things, well, there's a frame-by-frame analysis that the lawyers or anybody of authority can always just refer to. For future, the biggest enhancement that I want to see personally is what you see is even the real-time analysis, but the video needed to be uploaded in the first place. That's what I want to bypass. Possibly have a pipeline that keeps the video feed in the back end constantly being input, and then the user on the other end of the screen, they see analysis in the front in the real time as well. Hopefully you have a better model that can process more empty or used parking spaces in less amount of time, make it more complicated, basically again more scalable for a better use case. And then at the end, obviously, eventually just deploy it and get real users on this as well. Are there any questions about it?
Yeah.
That was the end. Yep, thank you. I'll stop sharing.
Thank you.
Who's next? Now I forgot. Who's after Ali?
It's gonna be me. It's gonna be the end.